Hi everyone, and welcome to our video on the congruent triangle postulates. I'm sorry this one was a little delayed. We've had, a lot of shakeups in the past couple weeks, so I haven't had the chance to really make a video for this, but we're going to go over it now. What we're going over is actually a part of the student activity sheet. So if you had not turned in the student activity sheet for this, you could just follow along with the video and get it taken care of that way, right? And pretty convenient. So what we're going to do is we're going to look at what we call the congruent triangle postulates, and those are a series of postulates that allow us to basically prove two triangles to be congruent without needing all six pairs. If you remember from the last video or from what we talked about a while back, right? Normally the definition of two congruent triangles means all their corresponding angles need to be congruent and all their corresponding sides need to be congruent, right? That's six pairs of information, which is a lot. But in math, we often can get just a couple pieces of information to find more information, right? Other things are locked in. For example, with triangles, right? If I know two of the angles, I can solve for the third angle because they add up to 180. So I only need two out of three pieces of information to get all three. With the pairs that prove triangles congruent, we will see a similar pattern. So on the Agile Mind, and I encourage you, follow along, try this out yourself. We're going to go through all of the possible triplets, so sets of three pairs of information, and see which ones will prove congruence and which ones will not. Now, we're going to use the word prove here, pretty casually because these are postulates, right? They're not proven to be true. They are assumed to be true because they definitely look like they guarantee congruence. We don't need to prove them, we're going to assume them. When we did this in class, we did it with a bunch of people all doing it together at once. So if none of us could find one that wasn't congruent, it was really likely that it wasn't possible to not be congruent, right? So how this activity works is I'm going to be building a triangle using these three sides and see, can I make this triangle not congruent, right, to the one that has been provided? So it's the same side lengths. That's what SSS means, three same side lengths. And what we would discover if you were to try this yourself, and again, I encourage you to try it yourself, right? Go on topic 10 and try it out, or topic 9. You will see here that I cannot build a triangle out of these pieces that is not the same. If I try to make the angle more shallow, my side length will not match up. So I need to raise my angle, and now I try to put it there, it locks in, right? A little shaky. There we go. And you'll see, it doesn't look the same maybe immediately, but once I rotate it or reflect it, all the rigid transformations that guarantee congruence still, it was still congruent, right? If I do this for all four of the triangles, even if you try it in different ways, there is no way to make a triangle with three side lengths that are the same that is not congruent to the one that we were provided. So to put this in other words, right, side lengths are another way of saying distances. So if I said walk in a loop 3 feet, then 4 feet, then 5 feet, the triangle you draw in your path is going to be the same triangle that I would draw. We might go slightly differently, right? You might go 5, then 3, then 4, or whatever. But we're always going to end up drawing the same triangle, just rotated or reflected. That's kind of interesting, right? Three directions that make a loop will always make the same triangle. When you do this yourself, you're going to need to test it for all four triangles just to really make sure there's no way to make it happen. Because as we'll discover, sometimes with some triangles, you can make it congruent, sometimes you can't, right? So here, I did it with all four, and I found, yes, this guarantees congruence. And I hope you tried the same thing as well. Let's check the next one. If all four sides work, is it possible to make all three sides, right? Triangles are three-sided. What about all three angles? Can I make a triangle that is non-congruent using all three of the same angle? So here I need to match up the sides, but notice the sides go on forever. I can make this any size I want. The angles are the same, but they could be different distances apart. So the question is, okay, if I change the distance, does it actually change my angle between the red and blue sides? And you'll notice, no, right? No matter where I put this, the angle at the top is still the same angle. As we already said, if you know two of the angles of a triangle, you know the third angle, right? But I don't know how far apart the angles are. Triangles can have the same angles as each other, but have different proportions from each other, right? Like a scale model. All the things have the same angles on the smaller, say, pyramid or whatever, but the size is different. So with proving them to be congruent, I need to check all four triangles. But when I find a counterexample, I only need to find one counterexample. Finding one instance where it is not congruent means I can't guarantee congruence. I need to be a lot more thorough with proving congruence, right? Because a single counterexample would ruin it. But I don't need to do as much for proving not congruence because, again, a single counterexample is enough. What about side angle side? Let's look at that one. So here I have the angle between red and blue, right? And I have the side lengths of red and blue. So if I was to do this in person, I might do it with my hands, right? My hands are not changing in size. I can pick an angle. So if I do this, what are all the different ways I can find a distance between my fingertips? There's only one way, right? Notice when I build this triangle, it doesn't even give me a choice on where to put the yellow side or where to arrange the yellow side, right? There's only one spot the yellow side can go. And that makes this very likely a congruent relationship, right? So I'm going to go through all 4 triangles. I recommend you do the same, and we're going to see if we can build any of them to not be congruent. All right, I did my 4 triangles and I couldn't get any of them to not be congruent. And you probably got similar results. Maybe you did differently than me. But all the triangles we made were not, were congruent, right? And I think if all of us can only make congruent triangles this way, that's probably what it is. There's still a chance we miss something, but it really seems like that when we build side angle side, right? What I've done is I've locked in this point just by making my reference. This point has to be a certain distance away and a certain direction away, and same thing here. So all 3 of my points have a locked in position. I have no choice on where to put my 3 points. If I don't get a choice on where the 3 points are in relation to each other, I don't get a choice on the triangle, right? So I think this is a yes. I think there's no way, and we would be correct. All right, what about SSA? SSA. So if I have a side, and then an angle, and notice this is different than SAS, right? I got the side length yellow, I got the side length blue, and I got the side, oh, sorry, the angle red. So see how it's a distance, and then a direction. That's different than a distance, a direction, and a distance, right? Saying go 4 feet, turn 30 degrees, then go 4 feet is different than saying go 4 feet, then turn 30 degrees, right? Those are different sets of directions. So you can see here, the way we built it is different. Before, I would have put it down here, right? And that's what it says on the bottom now when I've done that. The angle is not between the 2 sides. I need to make sure that the angle is this red side angle. So it looks like when I do it this way, right, that there's only one way to make it work. But maybe you were able to find something different, right? Because it seems like this is the one way to do it, but I can also make a triangle this way, right? And not a lot of people will notice this one because it requires you to go further, right? But maybe if you started from over here and we're going the other way around, right? Lefties might do that. You'll notice there's 2 triangles we can make here, not one. So even one more option is enough to not prove congruence, right? If I can make any triangle that is not the same as the triangle I was given, then that is not sufficient to prove congruence. SSA is one of the trickiest ones because seeing that second triangle is a little difficult, and not all triangles will have the possibility of making that second one. For some triangles, some parts of and pieces you're given, you can't do it, but for some of them you can. I like to remember that SSA doesn't work because in math is boring and you're not allowed to make fun words like SSA backwards, right? So we can't do that one. That's my way of remembering. Don't make an SSA out of yourself, is what my math teacher always said. All right, what about angle side angle? So again, notice here, this is different than side angle side, right? I'm clicking together my 2 angles, blue and yellow and red and yellow. And remember when we did this with 3 angles, I didn't know how far apart these angles were going to be. But now I do, because I've been told the exact distance away my second angle is from my first. And you'll notice when I do that, I don't get a choice on how to construct the triangle. I have my first point here, right? The direction I need to go in to get down here, and then the distance I need to go in that direction to get over here, and then the direction I need to go in to get to the first point, right? There's no choice involved. I don't get the ability to put any of those points in anywhere else. That's it. So if I was to go through all 4 triangles, and I encourage you to do this, I can't make a triangle that doesn't. So again, cooking show style, I just did it all off screen. Hopefully you tried it yourself. And I found that all 4 of the triangle parts I've been given, I cannot make them into a non-congruent triangle. Every time I did it, I didn't get a choice. When I clicked together the pieces, that was it, right? That's all I could do. The only thing I could pick is that the pieces were rotated or reflected, but that's not enough to make it not congruent, right? I need a choice somehow about that last point. Okay, so what about side angle angle? Well, once again, when I do this one, I need to match up my yellow and yellow, right? So these two angles, I don't know how far apart the two angles are, but I do know that these two angles are like this, but I do know where this blue line has to end, right? Because if I put this red distance here, I can't make them this far apart because then my blue line's ending over there on the red side. I can't make them this close because then my blue line ends too close. So even though I don't have the distance of yellow, right, like we did with angle side angle, I do have the distance for blue. By telling me where blue has to intersect red, I have given myself that third point, which means I don't have a choice. I couldn't have put this anywhere else because there was only one spot where it could have gone. Once again, this is going to be proven congruent, right? There's no choice involved. Now remember, I have to be careful and test all the triangles to make sure of this because like with SSA, sometimes I will not have a choice and sometimes I might. But in this case, I will say side angle angle, there's no way to make it work. There's no special triangles that are secretly not able to prove congruence. They all will guarantee congruence. So in the end, we have four relationships that prove congruence. These four relationships are side, side, side. So if I have the three sides of a triangle, I have triangle congruence. If I have three pairs of corresponding and congruent sides. If I have side, angle, side, so that's going to be three pairs, two of them sides and one of them angles that are corresponding or congruent with the angle between the two sides, like this, right? And this one is straight up just all three of the same side. Remember my congruency markings, right? Then I have angle side angle, right? And that one is going to be an angle, a side, and an angle. So it's going to look like this. And then lastly, I have side angle angle, which is a little different than angle side angle, remember? That's going to be a side length, an angle, and then another angle. But I don't know how far apart those two angles are. I just know the distance of that last side, right? Those are my three types of triangle congruence postulate. Those are the ones we got. I cannot use SSA. I cannot use AAA, right? Side, side, angle, and angle, angle, angle are not sufficient to prove congruence. These are the four triangle congruence postulates that we will be using. Now, if I give you these three pieces of information right off the bat, it's pretty clear, right? You would mostly just have to check the order for things like angle, side, angle, and side, angle, angle, right? But sometimes I'm not giving you all the information. We're going to use other things to figure it out. So in the next video, we'll talk about two problems that we'll very commonly see where we have to use some of the older things we've done to find that information. Okay? So look forward to the next video with some examples of applying the triangle congruence postulates. I'll see you then.